So in this video, we're going to talk about friendship and friend keyword in C++. It is one of those keywords that has been around like for decades, and this is not exclusive to modern C++. But we don't have any theoretical discussions. Without further ado, let's jump into some code examples. To save up some time, I have defined some very simple classes. We have the complex class, which is going to represent the complex numbers in mathematics. So we have a real part, an imaginary part, and a simple constructor. We have a particle class, which probably use more or less in every example that we have. It has a certain diameter. And then we have a droplet class, which publicly inherits from particle, and it has an exclusive data member called viscosity. Right now, our main function is completely empty, so let's jump in and try to generate a complex number called C1 and populate it with 1 and 2. The first thing I want to be able to do is to be able to print this value, to print this complex number to the console. So I want to say cout C1. If I do that, you see that Clang is uncomfortable. Taking a look at diagnostics, it says that invalid operands the binary expression std stream, aka also known as basic stream char and complex. So basically what Clang is saying is that last time I checked, I had no notion for this operator. I had no notion of a left-hand operand to be stream, output stream, and a right-hand operand to be a complex number, which is a user-defined data type. So you might say, hey, I got you. This is simple. I can do some operator overloading, and then I can solve this issue. I can say stream operator. And this is the stream insertion operator. As a reference, we send it. And all we want to do is to do a c.real. We want to print the real part, and we want to put a plus maybe to make it look good. And then finally the I, which shows that this is a imaginary part. And finally, I need to return my output stream. So you see that this error line is gone, but Clang is complaining about this one. Taking a look at diagnostics, it says that, hey, real and imaginary are private members of the complex. So here's the idea of friendship. In order to be able to print properly the complex number, we had to overload this operator. And in order to be properly show the real part and imaginary part, we had to access those private members of the complex class. How can I resolve that? This is the idea of friendship. I can go up here. Actually, I need to copy this line. I yank this line. And here in my complex class, all I need to do is to say friend keyword. And then I need to paste the prototype of that class. Even I don't need to mention the name of these objects. So I can remove this OS, and I can also remove this C if I wanted to. I mean, you can put it there for more clarity, but this is enough because all complex needs to do, it needs to do that this sort of operator overloading is a friend to the class. So now if you go down here, you see that now C, inside this operator, we can access the real part and the imaginary part. So friend functions and friend classes, we haven't tried friend classes already, but friend classes also exist in C++. You can define functions and classes as friends, and all it does is that it gives you sort of access to the private members of the class that you are being friend with. So right now, you see that Clang is happy, and I can also put a stdn line here. And let's check this out. I compile it and run it. You see that 1 plus 2i. It prints it very good, right? So now I want to draw your attention to the sort of this quote that we skipped in the beginning. This is a quote by Bjarne Stroustrup, the creator of C++. It reads as, friendship is neither inherited nor transitive. So what does this mean? The first part, it seems like friendship cannot be inherited. So inheritance has no influence on friendship. So let's go to our particle class. So here we can define, let's go down here actually. Let's define a particle inspector class, inspector function. And this particle inspector is going to take a const particle reference called P, and all it's going to do is to print the diameter of the particle, which is a private member. So it says P, D, and this is going to be something like that, right? If I do that, Clang is complaining, and it says that, hey, D is a private member, but we already learned about friendships. So all I need to do, I yank this line, and I come up here, in my particle class, I say friend, and then I paste that line, and I don't forget to put my semicolon. So this should be enough. So I can come down here, I can generate a particle P1, and I say the diameter should be 3 millimeters, and I can say, hey, I can inspect my particle, and I pass in my P1. Let's take a look at this. If I compile and run it, you see that correctly it shows that the diameter is 3 millimeters. So if I go back, but what if I wanted to have a droplet? So I'm going to pass in the same droplets. You see that, is it going to work? Because I'm publicly inheriting from this. Let's test it. If I compile it and run it, you see that, again, this thing works. So this is probably not surprising because droplet is also a particle, but it has something extra on top of it. But it publicly inherits from particle, so this means that it has a data member called D, and this particle inspector can inspect that. But can actually particle inspector have access to viscosity? So in other words, if particle inspector can have access to a particle, to droplet viscosity, it means that after I inherit, it means that friendship is also inherited to by default, or let's say automatically, to droplet as well, right? Because right now we only have friendship between particle inspector and particle class, not between droplet and particle inspector. So this means that if I come down here and if I say stdc out p dot viscosity and put a semicolon, you see that Clang is uncomfortable, and it says that, hey, there's no member named viscosity in particle. And that is quite obvious because we have friendship between particle inspector and particle class, not between droplet and particle. So this is the first basically part of the quote that Bjarne Stroustrup made. Whoops, what am I doing? I just wanted to comment this line. So now we already know that we cannot inherit friendship. But what is the second part of it? It says it's not also transitive. In order to understand that, let's make it very simple. Let's say if A is friend with B and B is a friend of C, will A be a friend of C? That's the question. And Bjarne has already answered it. Absolutely no. But let's take a look at it. If I have a class A, and I define it down here, which has only a simple private double member. It's of type double. And I want to just copy this thing and paste it and use it for B with private B and use it for C, whoops, with private C. So now we go back here. It says A is a friend of B, so this means that I can come here. I say friend class A. So now A is a friend of B. And then it says B is a friend of C, so I go down here, and then I say friend class B. So now B is a friend of C. But if A is a friend of B, what does it mean? It means that if I come up here and I have a, I don't know, void access sort of function, and I pass in a const B reference such as B, and then I say, hey, I want to access C out, I want to access B dot private B. This is what I want to do. If I want to do that, now Clang is complaining. Take a look at this. It says unknown type B. Oh, of course, because class B is defined after class A. So I need to do some declaration here. Say class B. So now Clang is not complaining about this anymore. It says that, hey, there's another error here. It says member access into incomplete type const B. So You provided here a declaration, but now you're trying to use something which I don't know what that is. I just know it exists, but I don't have any definition. So the solution for this one is either I take this thing up below or behind class A, I define it up here so that this error goes away, or actually I can take everything from here. I make this as a declaration, and after the definition of class B, I can say void a scope operator, access, and then I say const b reference b, just like that. And I can paste what I had before. So I need to remove these leading spaces. And there we go. Now Clang is happy. In fact, you can compile this thing and it works, right? So this means now we go to the question. The question is also A a friend to C? So this means that will I be able to say access, or let's say just I can use this line. Will I be able to use this for C as well, or no? Of course, I need to do the same declaration for this one as well. And I need to take this definition, make sure that you need to put it after the class C is defined. And here I want to say C and whoops. And I want to say C here as well. And here I want to access c.privacy. This is what I want to do. If I do that, you see that Clang is still uncomfortable. It says that, hey, private C is a private member of C. You no longer have access to that. So there we go. So that's the answer, which we already knew it, but we wanted to test it. So if A is a friend of B and B is a friend of C, then A is not automatically a friend of C. So that is basically what this quote by Bjarne Stroustrup means. So friendship is neither inherited nor transitive. So I hope you learned something from this video. This was friendship for classes and for functions, and hope to see you in the next one.